Okay, Dakota, this is for you, 9-4. I got started and then I was like, oh crap, I forgot to record. So, we've started example 1 just real quick, and I tell you to use the double angle identity, so we're looking at this cosine of 2x because that's really the problem in this equation. So we looked at our unit circle, which is where all of our formulas are at, and we have 3 options for cosine of 2x, or cosine of 2 theta. Now we chose to do the middle one because that's the only one that doesn't involve sine, because we want to switch them all to cosines so that maybe eventually we can factor. So we're using this identity for cosine of 2x, okay, and we're plugging in. So that's where we're at right now. Replacing the cosine of 2x with this part, all right? And then we factored, or we multiplied through the 3, all right? So that's where we're at right now. Okay, so now what? We want to put stuff in order.
Add the 3 over cosine squared first.
Okay, so let's put the cosine squared first. So 6 cosine squared x plus 5 cosine x. And I'm going to move this 3 over to this side. So I'm going to subtract 3. That will make minus 6 equals 0, right? If I've got a squared and a number, or a squared and an x and then a number, I'm going to end up factoring. So I want everything on the same side, okay? Now what? Cody's method? We'll see if Cody's method will work. I take 6 times negative 6, which is negative 36. I think it will, yeah. What can you multiply to get negative 36? What when you add them give you 5? Yeah, this is going to work nice. Multiply to get negative 36, add to get 5. One's positive, one's negative. Multiply to get 36. 9 and 4. Which one has to be positive?
It's like 6 and 6. Yeah.
Positive 9, negative 4 is what I want to do to get positive 5. Okay, so 6. And I'm just going to call this 6x squared. I'm going to switch these to x squared. Can I do that real quick? Because I don't like writing cosines over and over and over again. So I'm going to take that and then I'm going to make that 6x squared plus 9x minus 4x minus 6 equals 0. Okay, we'll switch them back to cosines here in a minute. But these two pieces together make the 5, right? Okay, now what?
Take stuff out.
You group and take stuff out. So out of the first piece will come like 3x maybe. And left over is 2x plus 3. And what are you going to take out of the second piece? Minus 2. And left over is 2x plus 3. Should be, anyway. Okay? So I've got these two pieces. I've got the 3x minus 2 and I've got the 2x plus 3. But they're not x's. I'm going to put the cosines back in there now. So I've got 2 cosine x plus 3 equals 0. And I've got 3 cosine x minus 2 equals 0. You guys see where I get those two pieces from? This guy right here, which is the same, and then what's left over. I set both of those equal to 0. Yeah? Are we good? Okay. Now, I am going to add the stuff to the other side. So if I subtract 3 and divide by 2, cosine of x equals negative 3 halves. Can I skip those steps maybe? Add the 3, divide by 2. Are we good so far? Okay. What about the second one? If I add the 2, divide by 3. 2/3. Okay, now that's what cosine of x is. We're almost there. What's that? Now how do I get just x? Do the thingy. Inverse cosine. Inverse cosine of negative 3 over 2. What's 3 over 2 as a decimal? 1.5. Where does cosine touch negative 1.5 at? Think of the graph of cosine. Where does the graph of cosine touch negative 1.5 at?
Never.
Never.
What?
He never touches it. He never goes that low, right? Okay? So if you do it in your calculator, you're probably going to get an error, right? Like cosine will not go down to negative 1.5, right? You get an error? So there's no answer for that one, but it should touch 2/3 at some point, right? So what's inverse cosine of 2/3? .841. There you go. So the first one we did not get an answer. The second one we did. So we just ignore the no solutions part and then we just circle the rest. Okay, good? So there's just one little piece from that, right? I know. All right, one little piece from that. Double angle identity. I think I headed this right. Is there a double angle identity that we can do? The first one? Yeah. Sine, cosine?
Yeah, equals sine 2x.
Somebody have their book open? That's 2 sine, cosine. I know. I know.
No answer.
This is kind of tricky. Yeah. Okay. All right. So there's an identity on your double angle identity right here, the first one, that says sine of 2 theta. It's sine of 2x. This is what it says. Sine of 2x equals, I'll give this back to Eric so you can actually see. Sine of 2x equals 2 sine x cosine x. Okay? But the problem is, yeah, you're right. But the problem is this is just sine of x cosine of x. Oh, you're close. Divide everything by 2. I want to for my identity over here, write it so that it just says sine cosine, right? So I'm going to divide this guy by 2 to make it like that, right? Well, I don't know. I can what?
Does that mean cosine?
2 is for the sine and the cosine.
Yes.
Yeah, so
Yes. This is like 2xy. Right? Yep. So we're going to divide the 2 over to the other side. So sine cosine is equivalent to this whole piece right here. So we're going to take this whole piece right here and replace the sine cosine. This guy right here becomes that. Sine of 2x over 2 equals 1.
What?
I don't think this doesn't have a solution.
Therefore, there is no solution.
Is that what the book says? Yay, great. Okay, so we're on the right track.
Can you
We're on the right
move
track.
it over?
So I was
Yeah.
right.
Okay. Okay, so did you guys see what we did to get the sine cosine? We want just sine cosine because we've got to replace this. So we divide the 2 over to the other side, and then we can take this junk and shove it in here, right? Okay. Now we want to solve for sine of 2x, right? Or we want to get sine of 2x by itself. So I'm going to multiply by 2, right? Times 2 times 2. So we have sine of 2x equals 2, all right? And then you remember solving these from a while back? We would try to get the 2x by itself. So don't divide the 2 over yet. We want to do inverse sine first. And then you would have like 2x equals that number, right? And then you would divide by 2, okay? But what is inverse sine of 2? Where is the sine function hit 2 at?
Never.
It doesn't. It doesn't. So this one will have no solutions because no solutions divided by 2 is still no solution. So you can't get an answer. Does that make sense? That was kind of a weird one. They just keep getting worse. Just keep getting worse. Okay, this one's not going to be bad. Okay, moving on to the next one. Double angle identity again. Cosine squared x minus sine squared x. Which one is that? Double angle. Cosine squared minus sine squared. The second one, which is equivalent to what? Cosine 2x is equal to cosine squared x minus sine squared x. Okay, so this whole thing we're going to replace with this. Okay, we're plugging the cosine of 2x. So I'm writing off to the side what identity we're using, in case you were wondering what that is. That's the identity that we are using. Okay. Now this one should be kind of fairly easy. Cosine of 2x equals 1/2. That's what we have right now because we've replaced this guy with the cosine 2x. Okay? Cosine 2x equals 1/2. Now what do you do? Inverse cosine, except the inverse cosine over here will get 2x by itself, right? I don't want you to use your calculator because we have 1/2 on the unit circle. Yes, right? Right? Above, we had to use our calculator because we didn't have 2/3 on the unit circle, but we have 1/2. Now, there are 2 places where cosine is 1/2 at, right?
Pi over 3.
Is he right?
Yeah.
Yeah? Pi over 3? Cosine is 1/2 at pi over 3. Where else is cosine 1/2?
Over 3.
Is he right?
Yeah.
Okay? At pi over 3 and pi over 3, yeah?
That's not in
But it's originally cosine. If this was inverse cosine to start with, that's a whole different story. We're only using inverse cosine to solve for it. We're not starting with the function of inverse cosine. Does that make sense? There's a difference. Okay. So we can set them equal to both of them, and now we have to get rid of the 2. Okay. So the easiest thing to do here, rather than dividing by 2, let's multiply both sides by 1/2. Does that make sense? Since we already have fractions, we'll make this easy. Okay. 1/2 and 2's are going to go away. So I just have x equals pi over 6, and I have x equals 5 pi over 6, and those are my 2 answers. Wow. That one wasn't too much writing, right? We had a lot of space. Look at all that white space that we didn't even use up. That was exciting. Woo! Okay. Are we good? Eric, are you doing all right? Let's go. Here we go. All right, next one. Use addition identities. Use an addition identity. Okay, so I'm guessing that we're going to have like some of this junk going together, right? Okay. Addition identities. I'm going to steal from Eric again. Addition, addition, addition. Okay. So look at the sum and difference identities here. We're going to match that up with what we've got going on. So this one is sine cosine plus cosine sine. Is the first one. Okay? And on your unit circle, they use u's and v's, whatever. U is 2x and v is x. U, v. Do you guys get that gist? Does that make sense? On your unit circle?
Top right corner.
Top right corner.
Sum and difference is identities.
Sum and difference identities. You see it? Okay. So sine cosine plus cosine sine. Okay, so what's that going to become? Sine of u plus v, right? Which is sine of 2x plus x, right? Because u is 2x and v is x. Does that make sense? What?
You have to leave the X.
Leave the x's in there. Yes. Yes. Because u is the 2x is taking the spot of u. So the entire thing of u is 2x. Okay? The entire thing of u is 2x. Okay?
Why is it positive?
What?
The positive X. Because if it's sine, cosine, minus cosine, sine,
Yeah.
you sine of u minus.
Yep. That's what the plus minus is. So rather than writing 6 identities here, they've slammed them into 1. Does that make sense? So if you're using the plus here, you use the plus there. Now, tangent is reverse. You see that? If it's plus here, then it's plus here and minus on the bottom. Right? That's why they do minus plus. There's a difference between plus minus and minus plus. So it's kind of confusing. Rather than writing 6 identities, they're trying to save room. So, kind of confusing. Anyway, so that's equal to 1. And now we have it like kind of consolidated a little bit. Sine of 3x equals 1. Okay, and then what do we do? Inverse sine. Now, you can plug into your calculator, but if there's more than 1, it won't give it to you. Is there a sign on, or is there a 1 on our unit circle for sine? At just pi over 2? That one only has 1. Ooh, pi over 2, not pi over 3. Pi over 2. Okay, there's only one place where sine is 1 at, and it's at pi over 2. Now, if you plug that into your calculator, it will give you a decimal, and I like pi over 2 better. So we'll use our unit circle. Use your unit circle whenever you can. And then, times 1/3, times 1/3, so x is pi over 6. Yeah. Yeah. Okay? Find the solution of... Okay? Find the solution of sine of x equals sine of x over 2. This is what we're solving. And we use a half angle identity. Now, you will not plug stuff into both sides, right? Sine of x, we're going to leave alone because he's nice. I like sine of x. That's as easy as it gets. But sine of the x over 2, we're going to use an identity for that, right? So I'm going to leave sine of x by himself. There are multiple identities for sine of x over 2, I think, right? Okay? Is there? I think there's only one, kid.
I'm thinking it's tangent.
Okay. Oh, disgusting.
Okay, nope, I lied.
Half angle identity, we're going to use this top one right here. Sine of x over 2 equals plus and minus, blah, blah, blah. Blah, blah, blah. Okay. All right. So, The half angle identity, the sine of x over 2 is plus and minus. Help me out here. The square root of, is it 1 minus cosine?
Cosine over 2.
X over 2. That's what we're replacing this sine of x over 2 with. Okay? All right? Good?
Yeah.
Good, good, good? Okay, now I'm trying to unwind this in my head. We're going to have sine and cosine. Oh, no. We're going to sine. E. Yeah. Okay, so now what?
Why?
Don't worry about the 0 to 2 pi. Don't worry about that yet. What?
Where?
Square the whole thing, right? Okay, so I'm going to take this guy and I'm going to square it. And I'm going to take this guy and I'm going to square it. Now, here's where the plus and minus goes away.
Hey,
If I take a positive number and I square it, it's going to be positive. If I take a negative number and I square it, it's going to be positive. So the plus and minus really doesn't mean anything in that case, right? I've just got sine squared x equals 1 minus cosine x over 2. Okay, now what?
Where's the thingy?
Actually, well, you could do it. Sine squared.
We're going to use a Pythagorean identity here in just a minute.
That's
Because
right.
here's the problem. We have sines and we have cosines, right? And I want to switch everything to the same trig function, right? So let's do something first. Let's multiply the 2 over to the other side. It doesn't matter what order you do this in. So we've got 2 sine squared x equals 1 minus cosine x, okay? Now it's all in a straight line. We have no fractions or anything, but we do have 2 different trig functions, sine squared and cosine.
We can add the cosine. No.
But they're still in the same trig
X
function.
to 1 minus cosine.
Okay, so sine squared, we have a Pythagorean identity that says sine squared plus cosine squared equals 1, right?
Yeah.
So if I want to substitute something in for him in terms of cosine, I'm going to bump this cosine to the other side, so I have sine squared equals 1 minus cosine squared. Does that make sense? You see that? Yeah? Yeah? So I'm going to take 1 minus cosine squared and plug him in there. So now I have all of them in terms of cosine. Okay? So, 2 times that whole junk there. 1 minus cosine squared x equals 1 minus cosine x. Okay, and then what?
You probably have to end up doing like
Distribute your 2. So 2 minus 2 cosine squared x equals 1 minus cosine x. Okay, get it all on one side, he says, because we're going to factor, right? We've got a square, an x, and just the numbers, right? Which side do you want to move it to?
Are we still both?
Well, what's my leading term going to be?
It's going to be negative term.
Cosine squared. I always like this first one to be positive, because I'm just that way. It makes it easier. So I would like to move everything to the right, right? It's going to like make things not so complicated, maybe a little bit. So let's move all of this junk to the left side, okay? So we've got 0 over here, 2 cosine squared x minus cosine x, and then if we subtract the 2 over, it would be minus 1. Does that make sense? Am I going too fast? Are we doing all right? You what? Okay, now what? Yeah, I like to change them to x's. 2x squared minus x minus 1. There you go. Makes it a lot easier. Makes it a lot less intimidating. I don't know if it's easier, but it's a lot less intimidating. What? Cody's method. Cody's method now. 2 times negative 1 is negative 2. Multiply to get negative 2, but add to get negative 1. So, negative 2, positive 1. So we just flip the signs around, basically. Okay? So, 2x squared minus 2x plus 1x minus 1. These two pieces will give me that negative 1x if I put them back together, yeah? Okay? Now, group. Group, 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 group. If nothing more, you guys will be like experts at Cody's method by the end of the year. If you don't learn any trig at all.
I think it's funny to call it Cody's.
Maybe Cody's method. I don't know. I need to find somebody else to name it after.
It's 2 years.
But you guys do good with Cody's method, and I have to name it after somebody who doesn't like it.
I've
Maybe
never
one of
used
Jamie's-
it until yesterday.
Until yesterday? Really? Girl, we'll name it Jamie's method now. 2x times x minus 1. What are you pulling out of the second piece?
You guys always talk about it, but I was
One.
like, I don't know how to do this.
Girl. Okay. All right, so my two pieces that I'm going to set equal to 0 are x minus 1 and 2x plus 1. But they're not x's, they're actually cosine of x's. Okay, so if I solve this one, I have cosine x equals 1. And the other one, I have, if you add the 1, or subtract the 1, divide by 2, what do you get? Cosine x equals, subtract the 1, divide by 2, Jazz said it, I think, negative 1/2. Okay, now, can you look those up in your unit circle? Yes, where is cosine 1? 0. Okay, cosine is 1 at 0 if I do inverse cosine. Okay, and then I'll show you why that's not right here in just a second, but whatever. Okay, so 0. Cosine of, where's cosine negative 1/2? There's two places. What? 2 pi over 3, is that negative 1/2? Okay, and the other one is 4 pi over 3. There we go, those are those two answers. Okay, now, here's the deal. The original question asked, last thing, we did end up using that whole page, the full page for number 5. The original question asked, tell me where between 0 and 2 pi that exists, all right? All of those numbers are legit between 0 and 2 pi, right?
It says equal to.
Except it's equal to 0 and equal to 2 pi. See the underline symbol? Okay? So cosine is 1 at 0, but it's also 1 at 2 pi, right? So we don't want plus 2 pi k, we just want to list 2 pi as an answer also. Does that make sense? Now, if it just said this, 0 is less than or equal to x is less than 2 pi, then that means you're including 0, but you're not including 2 pi. Does that make sense? This is getting down to like the nitty-gritty like details of everything, yeah? Okay, so we want to include both 0 and 2 pi because they're both the same place because it says equal to, yeah?
Yeah.
Okay, my goodness sakes.
Great balls of fire.
Great balls of fire. Oh my goodness, oh my goodness. I didn't tell you which identity to use. We'll find out. We'll find out.
Get the same answer one way or another. So why are sophomores taking the ASVAB?
Oh shoot, I gotta switch the video off. Bye, Dakota. Quit watching.
Or just middle column.